For today's lecture is signaling system number 7. Before starting up with its main parts, uh, I would like to go through some historical signaling systems that have been used over the years in telephony systems, and we'll see how it evolved into such a brilliant system that is still en vogue and is being used by all over the world. So let's see. First of all, what is signaling? Basically, signaling provides the intelligence needed for one subscriber to connect to others in that network. Basically, it is the information that is conveyed from from one user to the telephone exchange, and from that exchange to the exchange that is connected to our destination telephone set. So all this communication that is apart from the voice that will be passed through the network is signaling. From a user to or a caller to the telephone exchange, uh, a, a great number um, of information, different types of information has to be sent. For example, when the caller picks up the phone, this is itself a signal that is gone to the telephone exchange. After that, the telephone exchange provides a certain tone, which is the dial tone, to the telephone caller. That is a signal, and after that, the user, if he gets a certain continuous tone, which is a dial tone, which means that it is now allowed for him to start dialing a certain number. Then what he can do is that he can start dialing a number. Once he dials a number, this is another signal that is gone to the telephone exchange. Now, the telephone number that has been dialed, it might be related to the same exchange or to some other exchange. If it is related to some other exchange, then that particular exchange has to send that signal to the next exchange, and that exchange would be required to send relevant messages to the particular destination user. So in this way, there are many stages of this particular signaling. From one exchange to the second exchange, there would be some exchange of information regarding the voice channel that has been allocated or will be allocated, or when that particular call would end, that it would mean that the required um, resources are now free and idle and can be handed over to some new user. So in this way, similarly, as the call goes on, the signaling system provides a supervision of the call, and on the other hand, once a certain number is dialed and it is ensured that the proper communication network is available, then a certain ringing current is generated, which terminates at the telephone set of the target or the destination, and that ringing current is generated by the exchange to which that destination telephone set is connected to. It also gives the subscriber or the caller certain status. For example, the dial tone, the busy tone, because the end destination or the destination user might be busy in going through its own call. So in that case, the exchange will send back a busy tone. Or if a ringing current has been generated and it goes to this second or the target uh, destination, then a ringing tone would come back to the caller. In addition to that, the metering of the whole system, or the metering of the call, is also another important signal that is sent from exchange to exchange, and it also registers this information into the billing center, which records it, and also certain information is recorded in the relevant exchanges also in the form of CDRs, and the CDRs are call demand registers. Now, what type of signalings are there in a telephony system? If we have a general classification, we can have a subscribers signaling or inter-switch signaling. The subscribers signaling comes in between the telephone set and the exchange on either side, that is on the caller side and the callee side. And the inter-switch signaling comes in between two switches if the called subscriber relates to some other uh, exchange. The other form or the class of other classes of signaling are functional classes. For example, audio visual or supervisory or address signaling. Now, let's see what is the functional breakdown of signaling. The supervisory signaling, address signaling, and audio-visual signaling. We can uh, divide them further. For example, the supervisory signaling can be divided into the control signaling and status signaling. Control signaling is, for example, the seize signal, which is sent to instruct to seize a particular trunk in between, or hold, or release. Similarly, the status signals are like the idle. Uh, Idle means uh, that the user on the other side is idle, it's busy, or it's disconnected. These are the status backward supervisory signaling functions. After that, we have address signaling functions, which are station addresses or routing addresses. In the station addresses, we need to have a rotary dial or a push button number or a digital number that is incorporated. On the routing side, we have to identify the available channel or the trunk, and the information that a particular channel or a trunk is being will be allocated. That is done through address signaling. And the simpler one, that is the audio visual signaling, that includes the ringing or the paging or the off hook warning. Off hook warning means that if we put a telephone set off, if we put the receiver of the telephone set off the telephone set, then after a certain time it would initiate a beeping sound so that we can put it back in its place on hook, so that if an important call comes in, it is not wasted or lost due to being busy. So the other audiovisual tones are, or the signals are, dial tone and the busy tone and the ring back tones. Now we have different categories of signaling that we have already discussed, in which we have seen the audio-visual category as called as discussed earlier in the earlier slide. Then the alerting functions, for example, an off-hook signal, which is in the form of a beeping sound. That is one of those alerting functions. Now let's see in which form is this signaling sent. The signaling information can be transmitted by means of duration of pulses, because a certain duration of pulse would mean a particular function, or a particular status, or a particular instruction. There can be a combination of pulses. For example, we can have a combination of two different frequencies to identify a particular telephone number, a particular digit in the telephone number. Then we can have a particular frequency of the signal, which can through which we can identify a particular message, and it can be sent over our telephone network. We will see a little bit detail of this frequency a bit later. Then we have a combination of frequencies. We can have a presence or absence of a signal, which would a particular meaning to it. Similarly, we can send a particular binary code consisting of ones and zeros, which would mean a particular instruction or a status value. For the DC system, the direction or the level of the transmitted current also bears certain meanings. Supervisory signaling, basically, as we have discussed, it provides information on the line or the circuit condition and indicates whether a circuit is in use or idle. It would inform if it is the calling party, the information that you pick up a phone. It would give a certain information to the exchange that your telephone set is off hook now, or on hook if you put it back. So this is one of the important functions of the supervisory signaling, because the telephone exchange needs to know that either you have your telephone set on hook or off hook. If it is on hook, it means that it is idle. Otherwise, it means that it is busy. Supervisory information. It is the status that must be maintained end to end on every telephone call. For example, if you pull or lift your receiver on the telephone set, it means that the telephone exchange would understand that you are just going to request a particular service. The call subscriber, if he answers, it means that lifts his or her phone off hook, because that is when we may start metering the call to establish the channel. That would define as your target destination the person at your target destination, he or she picks up the phone, the metering of the call starts. The call and the calling subscribers return their telephones on the on-hook condition, then the charging would stop, and the intervening trunks comprising the talk path as well as the switching points are then rendered idle and would be used by the next coming customers. Uh, and it is important that the call is being supervised. Supervised means that uh, uh, on both the sides, it is monitored that uh, the telephone receivers are off hook on both the sides. If it is not, it means that the call has to be completed or closed, and all the resources associated with it have to be retracted and allocated to new users. Now, in the earlier systems in which the pulse type communication, pulse type uh, dialing was done. What was it? It was basically make and break of the current flow condition, which means that off hook and on hook. This was done to send a particular uh, digit of the telephone number. For example, if you are dialing 0, it means that your circuit has to be made and break 10 times. This is what a circular dial, if you have seen some in some older telephone sets, what it does. It does that. What it does is that you uh, you ring a 0 and you leave it, and it goes back using a spring loading system, and it basically puts on and off the main circuit of the telephone set 10 times. Similarly, if you dial 4, it would make and break 4 times. If you dial 1, it would make and break 1 time. Here you can see basically a diagram that shows the telephone exchange on the right hand side and the telephone set on the left hand side. You can see, let me point it out here. This is the subscribers loop. This is the portion in between this and this. This is the long path in between the telephone exchange and the telephone set. The telephone set is placed here, and the telephone exchange is here. Here you can see the mouthpiece and the headphone or the earphone of the telephone set, which are placed in the receiver part, and this is the hook switch, which normally is in the uh, break condition, which means that when it is in the break condition, it does not carry a current to this telephone set, but the current comes up to this point. So this gives you a very clear idea of the of the whole system. You can have you need to have a DC current from the battery system, which is placed in the telephone exchange over here, and here is the ringing generator, which is used for the telephone ring that you get when somebody calls you. In the earlier system, in the electromechanical systems, there were E and M. It was E and M signaling that was used. It was used for trunk supervision, particularly with multiplex equipment. Um, Now, historically, E and M signaling interface provides two leads between the switch and the trunk signaling equipment. One lead is called the E lead, and the other one is called the M lead. And the value of the current on both of these would determine a particular information. How can we have that information? First of all, let's see what are these. This is the trunking switch equipment, and this is the signaling interface exchange, and both of these have an M link and an E link. In this, on the other side, uh, here again we have an M link and an E link, and both of these are connected through some signaling medium. Let me remind you that we are talking about the oldest systems, the electromechanical exchanges. Here you can see that if we have a particular condition on at A and a particular condition at B, that would determine the status of the of both of these endpoints. For example, the signal from A to B, if it is that it is on hook, and B to A is also on hook, both of these are on hook, then M lead would be ground, or E lead would be open on A side, and on the B side the M lead would be ground and the E lead would be open. Similarly, if we have a battery on the M lead and open on the E lead, it would mean that it is off hook from A to B. And if it is ground on the M lead and open on the E lead, it would mean that it is on hook. Right. In this way, we can have different. This is also ground. Let me check this in the book also. Basically, this diagram is from chapter number 4. I've taken to discuss some historical methods of doing signaling systems, making signaling systems. This is basically, you can see that at page number 118 of our book, which is telecommunication systems engineering, and this is table 4.1. Sorry, earlier one. No, this is 113 page. So in the second row, in this row, this on hook would be decided by a ground on the M level and also ground on the E level. You can see this particular table on page number 113. So this we have already discussed. Let's move forward. Another method of signaling that has been adopted in history was EC signaling. And how was it done? And why was it done? First of all, the DC signaling had limits on the distance because of IR drop on the lines. DC signaling links can be extended, but it loses cost effectiveness also. So some form of AC signaling had to be used. In AC signaling, a low frequency AC signaling was used. It was basically in band signaling, but some out of band signaling was also used. Let's see what the frequencies that were. Low frequency AC signaling was used with frequencies below 300 Hz. For example, 50 Hz, 80 Hz, 135 or 200 Hz. But the problem was that we could at the maximum reach 80 to 100 kilometers, which means that these signals could be sent from 80 to at the maximum 80 to 100 kilometers by using or employing two repeaters at the most. So um, uh, so uh, the frequencies and the voice band were used, which is called the in-band signaling, which ranged between 300 to 3400 Hz. And the normally used frequencies were 2400 and 2600 Hz. 2400 Hz in one direction and 2600 in the other direction. And these two frequencies were used for line signaling as well as address signaling. In addition to that, multi-frequencies were also used. But there was a bit of a problem in band signaling, which was that at that time the telephony enthusiasts would basically hack the system and record or understand the sequence of the frequencies and try to do crank calls, which meant free calls, while using uh, the the signals relevant to the free calling numbers for their private usage. So we had to go for out of band signaling. For out of band signaling, 3825 Hz was preferred by CCITT, and it was used extensively on carrier systems but not on the wire trunks. The advantage was that all supervisory information was sent away from the speech, or the talk down could not occur. And the disadvantage was that when the channel patching was done, signaling leads have to be patched also. This diagram gives you a clear picture of single frequency signaling in band and out band. The A part, the diagram A shows in band signaling with the 2600 Hz, which lies in the speech band, while the B diagram shows the usage of 3825 Hz or 3700 Hz, which was used. 3700 Hz was used in the USA, while CCITT, which was basically monitoring the European standard, they used 3825 Hz, which was beyond the speech band. In such a system, if the circuit state was idle, the forward part, for example, in R2 line signaling, which used 3825 Hz, the forward part was turned on, and the backward or the return path was also on. It meant that the circuit is idle. If the forward part was off and the tone and the return was also was on, then it would mean that the circuit state is seized, or the circuit is seized. Similarly, if it is answered, then both of them are uh, tone off. If it is clear back, then uh, forward is tone off and the backward is tone on. So using these combinations, different signals were generated. So this was basically the history. Now, as the digital exchanges were popular all over the world by the end of the 80s, which used basically 64 kbps voice channels. So we needed signaling system which could provide the supervision of circuits, address signaling. It could carry call progress signals. It could alert notifications to be eventually passed to the called subscriber. So to do that, CCIT number 7 uh, was used. Basically, before CCITT number 7, a system which was CCITT number 6 was developed, which is considered to be the first packet data network in the world, well before the IP network. As you know, that the IP network is a data packet network. CCITT number 6 was also a data packet network, and its enhanced form is CCITT signaling system number 7, which is also a, a data packet network. What were the features of this signaling system number 7? It is internationally standardized as a general purpose common channel signaling system. It is a common channel signaling system. It is basically a data communication or a data packet network, but its sole purpose is to provide signaling or provide the communication of signals for telephony systems from one end to the other, which would include the exchange to exchange signalings also. So it is optimized for operation with digital networks where switches are stored program control. These are stored program control switches. For example, DMS 100, AT&T, ESS, 4 ESS and 5 ESS switches. All these are basically stored program control switches. This signaling system should be able to meet present and future requirements of information transfer for inter-processor transaction with digital communication networks, for call control, remote control, network database access, and management and maintenance signaling. This information basically all these functions should be done or should be possible through this signaling system. That's why signaling system number 7 is so successful till now. Even now, when a lot of network has been converted to voice over IP, still it is very much relevant, and it is being used all over the world. And it provides a reliable means of information transfer in correct sequence without loss or duplication of packets. CCITT signaling system number 7 was developed in 1980 and has become known as the signaling system for integrated services digital network. Without the infrastructure of SS7, ISDN could not be possible. And in parallel to that, signaling system number 7 is also used for the telephony all over the world. Signaling system number 7 is a data communication system designed only for one purpose, as I told, signaling, and it is not a general purpose system. Now, what is a general purpose data communication system? The TCP IP network system is basically a general purpose data communication system. SS7 is not. SS7, the core purpose of SS7 data communication network is to provide signaling for telephony system. What are the main parts of this signaling system number 7? The first part is the signaling point. Now, all the telephone exchanges have a mapping on a particular signaling point, and multiple signaling points are interconnected through links, and the set of all the links which connect up to a set of two or a pair of two signaling points is called a link set. There is a one-to-one correspondence between physical nodes and logical entities also. When there is a need, for example, a physical gateway node needs to be a member of more than one network. So it can be connected to more than one telephone exchange. And it may be logically divided into more than one signaling points, or a logical signaling point may be distributed to more than one physical node. By physical node, we mean a physical signaling point which is connected or placed in a telephone exchange and connected to that particular switch. It might be, what we are trying to say is that it might be serving another telephone exchange also. So this is a particular solid protocol on which careful administration has to be ensured. This diagram shows you the combination of signaling points and signaling points with transfer functions. The lines in between are the signaling links. The square parts with the diagonal line in between are the signaling points with STP functions, or the signaling transfer function, and the circle shows signaling points without signaling transfer point functions. Signaling transfer point function is a function just like routers. It means that it can serve as an intermediary signaling point between two different signaling points. So that is not all the exchanges have signaling points with this particular functionality. Only a few of them have, and those are called the signaling transfer points. Otherwise, the function of these signaling transfer points and signaling points is the same. The only difference is that these signaling transfer points help other signaling points also to send their relevant information also and receive their relevant information also. It relays that information. Signaling transfer point relays that information. Now, what are the modes of signaling? Messages between two signaling points may be routed over a link set directly connecting the two. This is called the associated mode of signaling. If two signaling points are directly connected through a link set, then it would be called uh, an associated mode of signaling. If they come through some other intermediary signaling points, then it would be called a non-associated mode of signaling. The signaling system number 7 is basically the quasi-associated mode, in which the routing is static except for, it is normally static, it does not change, it only changes in case of link failures or addition of new signaling points. Only in that case uh, uh, the change of routing takes place, and that's why it is called a quasi-associated mode. Signaling system number 7 does not include sufficient procedures to maintain in-sequence delivery of information. I would refer you to the TCP protocol of the which is the protocol of fourth layer in TCP/IP suite. In that protocol, we have a sequencing system also, using the sequence number of the packets. It does not happen in this signaling system number 7. There is no um, uh, sequence number system in this. Now, as I told you, the actual function of the signaling transfer point is to relay the information related to other signaling points, and while doing its own work of signaling for its own exchanges also. The signaling transfer function is concentrated in a relatively small number of nodes. Only a few nodes are used to have this particular function, because all the nodes do not require that. One more thing, in addition to the telephone exchanges, we do have SCPs also. SCPs are service control points, which are basically databases which are used in our signaling system. Now let's see what is the relationship of the signaling system number 7 to the OSI, Open System Interface 7-layer system. Let's compare it to that. First of all, the basic function of the signaling system is to ensure the operations, maintenance, and administration of the telephony network. And for that, we do not need a complete 7-layer OSI system. So, because we have a restriction of time to ensure the whole thing done. For example, we have a restriction of 2.2 seconds between dialing a telephone number and getting a response of either a busy tone or a ringing tone from the other end. We only have 2.2 seconds. To ensure that, we cannot afford to have more than 4 layers as compared to 7 layers in open system interconnection. As you know, in the TCP/IP suite, we have 5 layers: physical layer, data link layer, network layer, transport layer, and then the application layer. It has 5 layers. It does not have session layer and presentation layer. While in the case of signaling system number 7, we only have 4 layers: signaling data link, signaling link control, signaling network functions, and the user parts in SCCP. All the application presentation, session, and transport work is done in this layer 4. SCCP basically is an extension of the layer 3 functionalities, which is better done in layer 4. All the application parts are also present in this layer number 4. So we only have 4 layers in a signaling system number 7 data communication packet network. So signaling system, what is SCCP? Signaling connection control part. Actually, what we have done is that we have tried to force fit the signaling system number 7 to OSI from layer 4 onwards. So we need to have sub-layering in the layer 4, which includes the signaling connection control part and the user parts also. What are the user parts? User parts are the data user part, telephony user part, and the ISDN user part. If we talk about layer number 3, we can call it basically the MTP, or the message transfer part, which we can include uh, the layers 1 and 2 also in that. While the layer 4 comprises of the user parts, which are the telephony user part, data user part, and ISDN user part. Layer 1 defines the physical, electrical, and functional characteristics. And in the data network environment, 64 kbps digital path is the normal basic connectivity. Signaling link may be assessed by means of switching functions that provide the capability of automatically uh, uh, automatic signaling links. If this diagram, you can see the difference. Basically, we can see that we have got the message transfer part, which comprises of level 1, level 2, and level 3, while the level 4 comprises of the telephony user part, data user parts, signaling control uh, part, and the ISDN user part. In the layer 3, what it is just like the network layer. It is quite close to the network layer of the TCP/IP protocol suite. Here we have the signaling, message distribution, message discrimination, and message routing, which is a part of which are the parts of signaling network functions. And on the signaling network management part, we have signaling traffic management, signaling route management, signaling link management. The functions of the layer 2 are quite similar to the layer 2 of the TCP/IP suite also, which is the data link layer, but there are a few differences also. The main functions include the delimitation of signal unit by means of flags, flag imitation prevention by bit stuffing, error detection by means of check bits included in each signal unit, error control by retransmission, and signal unit sequence control by means of explicit sequence numbers in each signal unit and explicit continuous. signaling link failure detection by means of signal unit error monitoring and signal link recovery by means of special procedures. Layer 3 has two major categories, as we have seen already in the diagram, that it has the signaling message handling functions and signaling network management functions. Layer 4 has basically the user parts, which include the telephony user part, data user part, and ISDN user part. Some of the functions of layer 3, which are normally done in TCP/IP suite, are done by the SCCP part in which is in the layer 4 of the signaling system number 7. Some important terms in signaling system number 7. We've got signaling points, which are the nodes in the network that utilize common channel signaling. Signaling relations similar to traffic relations. Signaling links, originating and destination points, which are just like the IP packets. We have got the originating node address and the destination point address. Similarly, we have signaling transfer points and message labels. What are message labels? Let's see them in our notes. Then the signaling network functions. What are the signaling network functions? First of all, message routing, message distribution, and message discrimination. This is the same diagram again. There are three signaling network management function blocks, which are signaling traffic management, signaling route management, and signaling link management. The signaling traffic management functions are to control the message routing, which includes the modification of message routing, accessibility of all destination points concerned, and to restore normal routing. In conjunction with the modification of message routing to control the resulting transfer of signaling traffic in a manner that avoids irregularities in message flow. That we need to have flow control also. Similarly, we'll have message routing control, which is the control of message routing, and which is based on the analysis of predetermined information about all allowed potential routing possibilities, in combination with information supplied by the signaling link management and signaling route management functions for the status of the signaling network. Then the changes in the status of signaling network typically result in the modification of current message routing and thus the transfer of certain portions of the traffic from one link to another. Similarly, we have got signaling link management, signal management, signaling data link, which is done at the layer 1. There are some details, just go through them. After that, this is a signaling link, which is done at the layer level 2, and it's what are the responsibilities of layer 2. Signaling unit delimitation, signaling unit alignment, error detection, error correction, initial alignment, signaling link error monitoring and control. Here you can find the actual process of the whole thing, going from the layer 1 to layer 2. This is layer 3. Here there is layer 3. Layer 2 starts from here, in which we have got error detection, recognition part, congestion control, transmission part, uh, link status signaling units, come and go, and similarly the message signal units come and go from between this link state control part, and it is communicating with the signaling network functions on the layer 3. This is an important slide in which we have three different types of signaling units in SS7. The basic unit is only the fill-in unit, or FISU. What it does not have is the actual um, information that is provided in an MSU. In the LSSU, it only gives you this link status between two signaling points. And the MSU, this gives you the complete data. It provides the complete data. It shifts the complete data from one point to the other because it has got the SIUs, which is the service information octets, right? And we've got SIF, which is the signaling information field, which are not present in the other in this signaling unit and or this signal. Basically, all the three signaling units keep on moving between the signaling points and the signaling transfer points in the signaling network. You can see we have got SF over here, which is only the status field, because we are interested in knowing the status of a particular link using this particular uh, signal unit. But in this one, we have the complete information of signal information, and the service information of that also is present. This is the routing label structure, which gives you the originating point code, which is just like the uh, IP address of the source, and this is the destination point code, which is just like the IP address of the destination uh, host, right? So which are also part of the IP packet. Here we have got OPC and DPC, originating point code and the destination point code. In addition to that, we have got 4 bits for uh, signaling link selection if we have got multiple options. And as we have already discussed, it gives you the options in case a new signaling point is added to the network, or one of the links to a particular signaling point has failed, and another link has to take effect. And the first this field gives you the length of the bits be that would be coming ahead in the signal unit. Here you can see layer 2 over here and layer 4 over here, and the functionalities of layer 3, which include the routing and addressing, everything, uh, uh, routing and the traffic management and the link management, all done at the layer number 3. Also the message discrimination. Here we can see a procedure for initiating PSTN call. These are uh, different types of messages or the signaling or signals that are sent over the network or the signaling network to start up a call. I would recommend you to see the other presentation on SS7 that I have already shared with you on WhatsApp as well as on Teams, which includes a very nice simulation of this complete process, which includes initial address message, address complete message, and response messages. So all these are uh, uh, all these messages are used in that simulation to show how a telephone call is made. Now, what we have in signaling network structure, we have got signaling points, and each signaling point has its originating point code when it sends us a particular message to another signaling point, and the address of the other signaling point is defined as the DPC or the destination point code. Now we have another distinguishing factor between different signaling points, which are the national signaling points and the international signaling points. In this diagram, you can see different layers for that. Two countries have their connectivity over their international hierarchical levels, international signaling points, which are connected, and within those countries, they have different national signaling points, which connect within the country. Similarly, we can see international signaling points and national signaling points, and we have got two different levels. One is the international hierarchical level and the national hierarchical level. Now, as we have already discussed, the mm, the signaling connection control part, which lies on the fourth layer of our signaling system number 7 layer structure. It has some uh, responsibilities, which include um, some responsibilities of layer 3 also, as we are familiar with. So you can go through that also. Other part of the layer 4 are basically telephony user part, data user part, and ISDN user part. So using these, for example, in telephony user part, one typical messages IAM, or the initial address message. Then we've got address complete message, which is ACM. Uh, so just like this, we can have different messages in the DUP part or the data user part also. Similarly, we have certain messages in ISDN, which help to maintain an ISDN call also using SS7. Let's see in a little bit detail what is an IAM format. What do we have in an initial address message? We've got calling party category, then the heading code H0, H1, then we've got the label, then we've got address signals, number of address signals, then the message indicators. All these are present in initial address message. Now let's see what do we have uh, regarding signaling system 7 in the present world? Right now, as you know, that IP networks are in vogue all over the world. So it is always better to send our information, send our signaling over an IP network instead of using particular PSTN networks. For that, a particular standard has been developed, which is called SIGTRAN. It is a protocol defined by IETF, Internet Engineering Task Force. And there are three layers of SIGTRAN: standard IP network, then SCTP, which is basically the fourth layer, which is basically a fourth layer protocol in addition to TCP and UDP. Then we have got adaptation sublayers, which are M2PA, M2UA, and IUA, and SUA. SCTP is the third transport protocol in the same IP stack level as TCP and UDP.